What exactly is space-based solar power, or shortly, SBSP? Imagine huge satellites stationed in space, capturing solar power and then beaming it back to Earth using microwaves or lasers. Yes, you heard that correctly. It's a bit like something out of a Star Wars movie. But hey, what could possibly go wrong? Well, a lot of things. But before we go into that, let's first ask the main question. Why would anyone want to do that? Isn't it easier and cheaper to just install solar panels on rooftops or in deserts? Well, yes and no. You see, solar power on Earth has some limitations. For one thing, it's not available at night or when it's cloudy. It's affected by the atmosphere, which reflects and absorbs some of the sunlight. It's also limited by the surface area of the Earth, which is not enough to meet the growing demand for energy. On the other hand, space-based solar power has some perks that make it better than regular solar power. It's like the ultimate 24/7 party up there, where the sun never calls it quits. Plus, it's not affected by the atmosphere, which means it can collect more energy and avoid losses. No more cloudy days or smoggy skies. And on top of that, it's not limited by the surface area of the Earth, because in space, there is plenty of room to build giant solar arrays. I mean, go big or go home, right? Well, sounds like a sci-fi dream come true, doesn't it? Not quite. Here's the problem. Space-based solar power comes with a fair share of challenges. First off, the classic money problem. Launching and maintaining those space satellites can seriously drain the bank account. And even if we handle that, there's a tricky part. Sending energy all the way from space to our planet without creating chaos is like trying to hit a bullseye while blindfolded. We are not in an Avengers movie, guys. Using microwaves or lasers as power carriers has big potential threats to us. Imagine getting zapped by a giant space laser or fried by a cosmic microwave. Yeah, I think I'll stick to my limited solar power for now. But how does this whole thing actually work? Well, there are different designs and proposals for SBSP systems, but they all follow a similar principle. First, you need a solar power satellite or SPS, a huge spacecraft equipped with solar panels that convert sunlight into electricity. Then a power transmitter, or PT, comes into play. This device converts electricity into microwaves or lasers and sends them to Earth. And don't worry, there's a power receiver, or PR, waiting to catch those microwaves or lasers and change them back into electricity we can use. It's like a cosmic energy journey from space to our homes. While the whole idea might seem like a wild science fiction concept, some scientists have put SBSP to the test and proven it's more than just a cool concept. In 2020, the geniuses over at Caltech took the spotlight by successfully developing a working prototype of SBSP in a lab. And no, there were no mad scientists involved, just some really smart ones. They used 2 drones to mimic a satellite in space and a receiver on Earth. They were able to wirelessly transmit 10 watts of power over 150 meters with high efficiency. That's enough to light up a LED bulb, and a huge breakthrough for space-based solar power, or SBSP. Imagine getting clean energy from the sun 24/7, without any clouds or pollution in the way. That's the dream of SBSP, and these drones just brought it one step closer. The researchers hope that their experiment will inspire more interest and investment in SBSP technology. They're betting big that SBSP could be the game changer we've been waiting for, revolutionizing how we generate clean energy. Now, that's what I call a leap into the future. Alright, now let's talk about some countries that are aiming for the stars, literally. Take Japan, for instance. They've been head over heels about this SBSP thing since 2008. I mean, who wouldn't be? They've got a whole roadmap laid out. By 2030, they're planning to have a 1 gigawatt solar power satellite up and running. And wait for it, by 2040, they're aiming for a massive 10 gigawatt SPS. That's like going from a bicycle to a rocket-powered skateboard. They plan to use microwaves as the power carrier and deploy large receiving antennas on islands or offshore platforms. Rectennas, or receiving antenna, are antenna arrays that can receive and convert microwaves into electricity. They are like giant solar panels, but for microwaves instead of sunlight. Oh, and check out China. They've been in on the action since 2008 too. They're aiming for a 100 megawatt SPS by 2025 and cranking it up to 1 gigawatt SPS by 2030. But their plan is a little different from Japan's. They want to use lasers as the power carrier and deploy small photovoltaic cells on rooftops or balloons. If you're like me, you probably never heard of photovoltaic cells before today. You might be thinking, what on earth is that? Well, it's actually quite simple. They are devices that can turn light into electricity. And finally, India is also in the ring, exploring this SBSP idea since 2010. They're starting with a 10 megawatt SPS by 2025 and putting pedal to the metal for a 1 gigawatt SPS by 2030. All sounds great, but even in our modern era, cost remains the arch nemesis of progress. As Xiaodong Chen, the microwave expert from Queen Mary University of London, reminds us, building massive cosmic structures isn't exactly pocket change, after all. But hey, the economics are starting to change, though, with the commercial space industry driving down launch costs. The most ambitious timeline so far is for this technology to be ready to power homes and businesses on Earth by 2050, Chen says. So, by the time of 2050, we're all driving solar-powered space rovers. Just kidding. Anyway, by 2050, in order to meet climate goals set in the Paris Agreement, greenhouse gas emissions need to reach net zero. There's no chance of hitting that goal overnight. So, space-based solar shouldn't be seen as a competitor to Earth-bound solar farms, but a complement. The world needs as much renewable energy as it can get, as soon as it can get it. In the end, we might not be cruising in solar-powered space rovers by 2050, but we're definitely on a journey toward cleaner energy. And what if I told you that you can speed up the process by liking this video and subscribing to the channel? Yeah, that would be a lie, but seriously, I hope you enjoyed this video and learned something new. If you did, please give it a thumbs up and leave a comment below. And if you want to see more videos like this one, subscribe to the channel and hit the bell icon to get notified when we upload new content. See you next time.